Okay, guys, here we are back. And what this is going to mean is you've watched 8.2 part 1. You've watched 8.2 part 2. Now, this is going to be one final example, putting the whole song and dance together of how do we apply 8.2 to problems. And then we're going to go through a summary. What do you need to do for every 8.2 problem? What do you got to walk away with knowing? So let's do our final example here. Instead of winding through mountains, some roadways possess tunnels that cut through the mountains. However, too many vehicles in a tunnel at the same time can be hazardous. Traffic engineers decide to investigate this by examining a long tunnel in Colorado. If X represents the time for the vehicle to go through the tunnel, it is known that X has a distribution with mean, mu equals 12.1, and standard deviation, sigma equals 3.8. For a vehicle to be safe, it is reasoned that on average they should be in the tunnel between 11 and 13 minutes. Typically, there are about 50 cars in the tunnel at a time. What's the probability that the mean time for vehicles in the tunnel is from 11 to 13 minutes? Like the rest of the videos and like the rest of the section, oh my gosh, so much. Folks, you've got to break these down. Start by identifying the question. They want to know what's the probability the mean time for 50 vehicles in the tunnel is from 11 to 13 minutes. Okay. I know I've seen problems where they want the probability for a given range in time. And I needed to use normal CDF there. But I don't know if I can use that here or not, so I got to determine that. But before I go any further, give away any answers. If you feel good, try it on your own. As always, pause the video, check your work with mine. If not, follow along with me. So here's where I'm at. I've identified the question. I'm thinking I'm probably going to use some form of normal CDF, just given on how the question is phrased. They give me a range of values and they want a probability. But I know I can't do that until I determine if it's normal. So really, before I get all confused, I'm just going to identify the important pieces of information they give me. I know that the population mean is 12.1, and the population standard deviation is 3.8. And I know my sample size is equal to 50, right? I'm looking at about 50 cars in the tunnel, so I can take those 50 cars, take an average, and that'll give me my sample mean. What's the average time it takes a car out of the 50 to get through the tunnel? Okay. My number of samples would be the amount of times I look at this data for the 50 cars. Sample size, though, is 50. Okay. I've got my information. The question becomes, is the distribution of sample means normal? Okay, the question is asking me the probability that the mean time for 50 vehicles. They're not asking for a single vehicle, that I just pluck a single vehicle out of that tunnel and I go, how long did it, or what's the probability it took that single vehicle between 11 and 13 minutes? They want the average for 50 vehicles. They want the average for the sample. What they want is for me to look at the distribution of sample means. You've heard me say it time and time again. We have our population distribution, then we have our distribution of sample means. We have a single car being taken out of the tunnel, out of all the cars that go through, or we have the average of 50 cars going through the tunnel. Okay, do you see the difference there? Taking out a single car versus looking at the average of 50 cars. Looking at the average, or looking at the average of 50 cars and looking at the distribution of those averages is the distribution of sample means. Looking at just the distribution of all the cars is the population. Since we're talking about the probability that the mean time for 50 vehicles is, I'm looking at the distribution of the average time for 50 vehicles. So if you want to relate it back to the trout problem, I'm not looking at a single trout out of the pond. I'm looking at the distribution of those 100 sample means, those 100 means that the kids found of their trout. So what am I going to do? Well, before I can use normal CDF to solve this problem, I have to determine if the distribution of sample means is normal. We have two ways of doing this: central limit theorem, or theorem 2, or theorem 1. Well, theorem 1 says I have to know if the population is normal. And according to my information that I'm looking at, I don't see anywhere that it's saying that X has a normal distribution. It says that X has a distribution, but nowhere does it tell me that the population is normal. So that's out. Theorem 1's out. But my sample size of 50 is larger than 30. Since my sample size of 50 is larger than 30, I know that the distribution of sample means is normal. Is the distribution of sample means normal? Yes, by the central limit theorem, or theorem 2. Since our sample size is greater than or equal to 30. It's 50. Okay, I've established my data. I know what the question's asking me. They want me to look at the distribution of sample means and find the probability that an average time of 50 cars going through the tunnel is between 11 and 13 minutes. So now that I know the distribution of sample means is normal, what I can do is I can set it up, my normal CDF, and solve. My left bound will be 13, or 11. My right bound will be 13. What's my mean of my distribution of sample means? Again, we're working with the distributions of sample means. We got to find mu of x bar and sigma of x bar. Well, one of the consequences of the central limit theorem is that the population mean equals the mean of the distribution of sample means. So my mean is still going to be 12.1. But when we're working with the distribution of sample means and not the population, our standard deviation isn't sigma. It's sigma over the square root of n. So the standard deviation for my distribution of sample means will be 3.8 divided by the square root of 50. Okay, which actually, if we calculate 3.8 divided by the square root of 50, it is 0.54. Okay, so I've set up my normal CDF, I solve, and I get 0.93. In other words, there is a 93% chance that the average time it takes 50 cars to go through the tunnel is between 11 minutes and 13 minutes. Consequently, if they asked me something along the lines of, should you be concerned if the average time for 50 cars to go through a tunnel is outside 11 to 13? Yes, I should. Because 93% of the time, the average time for 50 cars to go through is between 11 and 13. So if it's not in that window, I am concerned. Okay, again, to summarize, what we're doing is we identified our important pieces of information, U, sigma, n. We identified what the question was asking us. They were asking us about the distribution of sample means, not the population, because they said the mean time for 50 vehicles. So they want the distribution of the mean times for 50 vehicles. And then what we did is we said, okay, well, we need to use norm CDF to solve the problem. But before we can ever use norm CDF, we have to identify if the distribution of sample means is normal, which it was because our sample size was greater than or equal to 30. We set it up, we solved, and now here we are. So here's the summary. The whole summary of 8.2. Here's what you got to know. The simplest way I can boil this down is the first question you all ask yourself as you solve these problems. Is the distribution of sample means, the X-bar distribution, is it normal? And we have two ways of telling if it's normal. We can look at the sample size, and if it's greater than or equal to 30, the central limit theorem, theorem number 2, then the distribution of sample means is normal. Or we learned in the first part of 8.2 that if the population was normal, according to theorem 1, then the distribution of sample means is normal. Remember, we don't make predictions about the population. We use these theorems to determine information about the distribution of sample means, not the population. Okay? The population is what the population is, but the central limit theorem and theorem 1 help us determine whether the distribution of sample means is normal. Number 2, if the distribution of sample means is normal, whether by theorem 1 or 2, we will typically use NCDF, normal CDF to solve. We'll use our left bound, our right bound, and our population mean. Why just our population mean? Because our population mean equals the mean of our sample means. The mean of the distribution of our sample means equals the population mean. Okay, they're one and the same, given that the distribution of sample means is normal. If the distribution of sample means isn't normal, you're not even messing with it. You're saying you can't solve it. Okay? So if you get to step 1 and you're like, neither criteria, theorem 1 or theorem 2 is met, you can't solve the problem. But if that's the case, if the distribution of sample means is normal, you're probably going to be using norm CDF, and the mean of the population is the same as the mean for the distribution of sample means. What about the standard deviation, though? Well, the standard deviation depends on the question they're asking. If the question is being asked about the population, they're taking a single trout out of the pond, they're taking a single car out of the tunnel, then we will use our X distribution, and we're just going to use sigma. If, though, they're talking about what's the probability of the average of 50 cars going through between 11 and 13 minutes, what's the average length of a sample of 5 trout, and is that between 8 and 12 inches? If they're talking about the distribution of sample means, we're going to plug in sigma over the square root of n into our standard deviation, because that is how we find standard deviation for the distribution of sample means. The standard deviation piece of normal CDF is going to change depending on the question. The question's about the population, a single trout, a single car in the tunnel, use your population standard deviation. But if they're talking about the distribution of sample means, the average of 50 cars going through the tunnel, the average of 5 trout, the mean, then we will use our standard deviation for the distribution of sample means. And it'll be sigma over the square root of n. Guys, I hope this helps. I know it's really hard to learn over video. Let me know what questions you have, and we'll work through it together.